So I said that the exponentials were going to be our last new family of functions. And now here we are introducing a new function, the logarithm. The logarithm is part of the same family of functions as the exponentials. They're closely related in that one is defined to be the inverse of the other. We knew that the exponential had an inverse because it was 1 to 1. But none of the functions we already had were that inverse. So now we're defining a new function called the logarithm. And the way that we're defining it is, if we have an exponential with a base b, its inverse is called the logarithm base b. Notice these three symbols, log. Notice that in print they're not italic. That's a clue that they're not variables. Variable names are italic when we print math, but log in the name of the log function is not. Don't look at this as a separate L, O, and G. That log you should be seeing as one symbol. So the number b is called the base, just like it was in the exponential function. Those have the same name for a reason. And then the number that we're taking the log of is called the argument. And I'm not going to test you on those terms, but I am going to use those terms. And the things I say about the log will make more sense if you include those terms in your vocabulary. Just like exponential functions were, logarithm functions are defined for bases that are positive and not 1. And that's just like the exponential functions. And that's why, right? A log function needs an exponential function to be the inverse of. So if we take the inverse of an exponential function, it has a base that would be a legal base for an exponential function. So for the moment, let's just practice this notation. Any statement involving an exponent can be rewritten as a statement about a logarithm. So if we say that 5 to the third power is 125, we can rewrite this in logarithm form. We'll start with the log. And when I write log by hand, I like to write it in cursive so that the letters are joined together so that it's easier to see that it's just one symbol. You don't have to do that, but you should be aware that I'm going to. So log, the base is 5, so the base of the log is 5. And then the exponent and the argument switch places. The log base 5 of 125 is 3. And since the original statement is true, 5 to the third really is 125. The statement about logs is also true. We can also go the other way around. So here we have a statement about logs. Log base 3 of 81 is 4. And we'd like to know whether that's true or not. So we're going to rewrite it in a familiar form. So when we do that, the base stays the same. And then the argument and the exponent switch places. 3 to the fourth is 81, means the same thing as this statement. And now 3 to the fourth really is 81. So the exponential statement is true, which means that the statement about logs is also true. Like other functions, we can compose logs with something linear and still have a log function. So we can have something linear in the argument, and then we can also do something linear to the log. If we only have one term in the argument, so something like this, the parentheses around it are optional. We'll typically include the parentheses if we really want to highlight that that's what we're taking the log of. Otherwise, we'll leave them out. So if you're ever in doubt as to whether you need parentheses around your argument, put them in. It's never wrong to include them.